In this presentation, we're going to continue on with the normal distribution. And what we're going to do is look at a special case of the normal distribution called the standard normal distribution. Now, just to be clear, this means something specific in the context of studying normal distributions. The standard normal distribution, or the standard distribution as you just can call it simply. So a random variable having a normal distribution with a mean of 0, I'm just going to write this below down here, mu equals 0, and a standard deviation of 1, sigma is equal to 1, is said to have a standard normal distribution. So actually we might write this as follows actually. So I'm going to start introducing this notation. I haven't really introduced it yet. So we might sort of say something like this: n 0 and 1. Now actually I'm going to square that there for a second because the reason for that will become clear later on. So the mean, and actually that is the variance. So the variance is also 1 squared, which is also equal to 1. So that's why that is 1 there. So those are a couple of important remarks to start off with. So it's always 0 for mean and always 1 for standard deviation. Now, this is how we might look at it on the bell curve. And again, the mean there is 0. So the center line here is on the number line. It's just 0. Okay. The standard deviation is equal to 1. Okay, so that controls the width of the curve. And also the letter Z or Z is used to designate the standard normal random variable. So I'm going to start using this, the Z distribution, or if you're in the US, the Z distribution. So I'm going to start using that as a sort of nickname for the standard normal distribution. So moving on from that. Now, this is a very important formula here. So if we have a normal distribution, a general normal probability distribution, we can convert values to the standard normal distribution. That is to say, we can compute their Z-scores. Okay, so the equivalent score from the standard normal distribution is called the Z-score or Z-score. Now, so this is what we might do when we're calculating it there. So when we have a normal distribution with mean mu and standard deviation sigma, what we can do is for some value x, we can find the corresponding z-score. Okay, so we can think of it as z as a measure of the number of standard deviations x is from mu. And by the way, it applies to all probability distributions, including the standard distribution, but there's not really much of a point to it then. So this is a very important formula, and we will call this just simply the standardization formula from now on. Okay, so that's how we will compute z-scores. So this is one formula that is always well worth remembering. It's very simple to remember as well. Now, I'm going to explain a few more things about it as we go. So I've just introduced a few basic concepts. There's a couple of things that need to be best demonstrated once we look at them through the context of examples. So here we have an example. We have this motor oil company, or Pepzone, sells auto parts and supplies, including a popular multi-grade motor oil. When the stock of this oil drops below 20 gallons, a replenishment order is placed. Okay, so this just gives a general context in the terms of a real world example. Let's move on. So, did I skip one there? No. The manager is concerned that the sales are being lost due to stockouts while waiting for an order, and it has been determined that demand during replenishment lead time is normally distributed with a mean of 15 gallons and a standard deviation of 6 gallons. Now, just when you're reading an exam question like that, those things should stand out at you immediately. Okay, so we'll just sort of say up top, mean equals 15, and standard deviation is equal to 6. Okay. The manager would like to know the probability of a stockout, the probability of x greater than or equal to 20. Okay, so that's what we're being asked here. Okay, so we've got everything we need there. We've got the vital pieces of information, and also we have got what we're being asked for. Now, let's move on from this. So, solving for the stockout probability. First off, we're going to convert x, the some value x, to the standard normal distribution. We're going to convert the z-score. Now, in this case, we're asked for probability of x greater than 20. Okay, so what we want is the z-score for x. So what we're going to do is use this formula here. Now we know that mu is equal to 15, and we know that the standard deviation is equal to 6. So that's where the 15 here and the 6 here comes into play. Now we're dealing with x equals greater than equal, or x is greater than 20. Okay, so that's what we're being testing in particular. So x here is going to be 20. So convert x to standard normal distribution. So it's a very simple calculation here. 20 minus 15 divided by 6, that's equal to 5 divided by 6, which is equal to 0.83. Just as a remark, actually, it's best just to leave your answer to 2 decimal places. You'll see shortly why that is. Now, that's the first step done. That's a big step. The standardization formula computing the z-score. What we're going to do now is find the area under the standard normal curve to the right of z equals 0.83. Okay, so we're going to go on to the next slide here. So in general, what we do is we would go to the probability distribution, or the probability tables that we would often have when carrying out such a course. Now, in this instance, in the course, in this probability table I would use for the normal distribution, I would use what they call the complementary cumulative probability table. Okay, so how would you know up at the top? How would you know which tables you're using? So you're right, there's actually 3 types. There's the cumulative and the complementary cumulative. Now, in general, what happens is you should have a little image up at the top of your page, and a complementary cumulative will have a sort of image like this. Okay, a cumulative would have the opposite. So it would have something like this here. Okay, now that's best dealt with in a different presentation, but again, it's something to be mindful of. Okay, now, so what I'm going to be asking here, now what particularly you're interested in is this is the standard normal tables, the standard normal probability distribution, and what this does here, it computes the probability of z being greater than or equal to some particular value z. So I'm going to give that z as the name of the variable, z is a particular value. For example, 0.83. Okay. Now, so how do we find it here? So we're going to break this up into 2 parts. So our number here is 0.83. We're going to proceed with 0 point. Now, so what I'm going to do here is we're going to have it to 3 digits, so 0 point or something point something something. So to the for the values just immediately adjacent to the decimal point, we're going to have that as one component of the number, and then the other component here is the second decimal place, the number in the second decimal place. That's the second component. Now, 0.83, if just down at the bottom of the page there, we can rewrite this as 0.83 equals 0.8 plus 0.03. Okay. Now, this gives us the row. This number here is the row, and this number here is the column of what we're going to be doing. So I have it sort of done out here. So 0.8 is the row. So here we have it there, circled here. There we go. And what we do is we go over till we reach the column where we have 0.3, And therefore the answer is 0.2033. So the probability of z being greater than or equal to 0.83 is equal to 0.2033. Now the things are getting a bit cluttered there, so I'll move on to the next slide to continue this point here. So compute the area under the standard normal curve to the right of z equals 0.83. So there we have it there, 0.2033. Okay. Now, what's the point of that? The point of that is, what we're being asked first off is, let's put all this together. What we were asked first off, what is the probability of x greater than 20? Well, that is equivalent to the probability of a z value being greater than 0.83, and that is equal, from the tables, 0.2033. So this is an important part here. This is 0.83 is the z-score of 20. So when we were dealing with some some general probability distribution, we find the corresponding z-score, and we can use the probability tables to evaluate things like this and get answers like this. Okay, so the probability of a stock out, probability of x greater than or equal to 20, is the probability of z being greater than 0.83, and the answer there is 0.2033. So that's it there. This is this is the bell curve now, and so just as a quick remark, if you were using the complementary tables rather than the cumulative complementary, you would have got this here, 0.7967, which is the probability of x less than or equal to 20. So here we have the z values here at the bottom. Okay, and what I'm going to do here is write in the corresponding x value, so 15 and 20. Okay. So, that is as much as we're going to do in this presentation. So I'm going to set up for part 3 now.